Here are Unit 5, Day 7 assignment solutions. So we're asked to graph an equation y equals x squared. And we're given the following x values to fill in. So we just plug those, substitute those in, and get the following y values, which will give us the following coordinate pairs. And when we graph this, we get a parabola which looks like this. It's only touching the x-axis at one point, so there's only a single x-intercept. Our next equation is y equals negative x squared minus 2. There is a negative sign in front of the x squared coefficient, so we're expecting it to face downwards, which it does. Once we substitute in our x values, we get the corresponding y values. So these are our coordinates for this particular equation. Now this one is a little bit interesting in that at no point does the graph cross the x-axis. There are no x-intercepts at all. So it's a little bit different from the ones that we're used to seeing. Here we've got an analysis of a parabola. So this is the graph that we're given, and we're asked to draw the axis of symmetry and state its equations. Well, the axis of symmetry goes right through the vertex, halfway between the two x-intercepts. So its equation is x equals negative 2. We're asked to draw and state the zeros, or the x-intercepts, negative 4.5 and positive 0.5. Our y-intercept, where the graph crosses the y-axis, which it does at negative 1. The direction of the opening of the parabola is up. And the vertex is negative 2, negative 3. And we can see that just by watching or looking at the graph. We see the point at which it starts changing direction and heading the other direction. And it does that at negative 2, negative 3. Here's another parabola. We're asked to draw the axis of symmetry and state its equation. Well, this is the midpoint, or the dividing line, of the parabola. It occurs at x equals 1. The zeros are the x-intercepts, the 2 points where the graph crosses the x-axis, and these are at negative 1 and at 3. The y-intercept, where it crosses the y-axis, is negative 6. The direction of the opening of the parabola is up, and the vertex is right here at 1, negative 8. Here we're given an equation, and we're asked to graph the parabola. The y-intercept is this point right here, the c value, which is negative 8. The x-intercept, well, what we have to do here is we have to factor this particular equation. So we're looking for a pair of numbers that multiply together to be negative 8 and add together to be 2. And that pair just happens to be positive 4, and negative 2, which will make our intercepts negative 4 and positive 2. We get our axis of symmetry by adding up our two x-intercepts, negative 4 and 2, and dividing by 2, which gives us a value of negative 1. So our axis of symmetry is x equals negative 1. And once we know the axis of symmetry, then we have the x value for the vertex. And if we plug that x value into our original equation, we're given a y value for the vertex. So we'll plug that negative 1 in. We come up with a value of negative 9. So our vertex is negative 1, negative 9. Actually, this is a mistake, which I will fix. In this question, we're asked to complete the table of values and graph. So our equation is y equals negative 3x plus 2. We're given each of the x and y values for a number of coordinates. So we can just write them in this form. Now, to calculate our first difference, we have to take 5 minus 8, which gives us negative 3. The next one, 2 minus 5 is negative 3. Negative 1 minus 2, negative 3. For each one of these, the first difference is negative 3. So when the first difference is the same, we have a linear equation, or a straight line, which makes sense because there is no x squared anywhere in this equation. All the first differences are the same, and therefore we're left with a linear equation, which is a straight line. This equation, x squared minus 2x minus 3. This does have an x squared in it, so we might expect it to be a parabola. Once again, we're given the x and y values for a number of coordinates, which we can fill in. Now, to calculate the first difference, we take 0 minus 5, gives us negative 5, and we work our way down and calculate the rest of the first differences. As you can see, all our first differences are not the same, so we do not have a linear equation. So let's do the next one and see if we can come up with a second differences are the same. Negative 3 minus negative 5 is 2. Negative 1 minus negative 3 is 2. 1 minus negative 1 is also 2, as are the remaining ones. So our second differences are all the same, which tells us that our relation is a quadratic. And when we see it graphed, we can see our familiar parabola. An archer shoots an arrow at a target 20 meters away. The following data shows the height of the arrow above the ground at various times after it was shot. Complete the table. Okay, so these are like our x and our y values. Our time will be along the x-axis, and our height will be along the y-axis. Here's our first differences that we get from subtracting this from this, this from this, and so on. And as you can see, none of these first difference values are the same. So we know it's not linear. Well, let's do the same with our second differences. 0.86 minus 0.94 gives us 0.08. 0.46 minus 0.86 gives us negative 0.40. and so on as we work down the second differences table. And you can see that none of the second differences are the same. So this is not a quadratic. The first differences aren't the same, so we know it's not linear. The second differences are not the same, so we know it's not quadratic. Now, if you look at the points, it looks like it's a parabola, but we've proven that it's not a perfect quadratic equation simply because the second differences are not the same. We're asked, what is the maximum height of the arrow? Well, we can just go up to this point right here and see that approximately 3.62 is the maximum height. Then we're asked, what height was the arrow shot from? Well, when the arrow was shot, the time is 0 seconds. So we'll start at 0 seconds and then see what the height is. And we can see that the height is 1.18 at that point. So our maximum height, 3.62 meters. The height of the arrow when it was shot, 1.18 meters. Next question. A quarterback let me try that again. A quarterback passes the football. The ball follows the path indicated by the data below. Complete the table. So we can do our first differences. 12 minus 2 is 10. 18 minus 12 is 6. 20 minus 18 is 2. So we're getting an idea that our first differences are not the same. This tells us that our quarterback, or the ball at least, the path of the ball is not linear, because these are all different. All right, let's check out the values for the second differences. 6 minus 10, 2 minus 6, negative 2 minus 2. As you can see, all of the second differences are the same. And this tells us that we have a quadratic relation. And there's our graph. And the question's up here, what do the first and second differences tell you about the graph? Well, because the first differences are not the same, it tells us it's not linear. Because the second differences are the same, it tells us that the relation or the graph is quadratic. Approximately how far has the ball traveled when it hits the ground? Well, to get that, we have to look at our height, where height is 0 again. And we can see that it's approximately 62 meters. How far had it traveled when it was 10 meters in the air? Well, this is a little bit of a tricky question because it's 10 meters in the air 2 times during this throw. It's 10 meters in the air when it's first thrown and it's heading on an upward trajectory, and it's also 10 meters in the air when it's heading downward. So we'll have 2 answers for this, 7.8 meters and 52 meters.